In this video, we'll write the balanced net ionic equation for chromium-3 sulfate plus ammonium carbonate. So to do that, we first need to balance the molecular equation. This is our molecular equation. It's a little bit intimidating, but I can see right away I have two ammoniums, that's good. But I have one sulfate here and then three of them here. So I'll put a 3 in front of the ammonium sulfate. That balances the sulfates. Now I have 3 times the 2. 6 ammonium ions. So I'm just going to put a 3 here. 3 times 2, 6 ammonium ions. 3 times the 1 carbonate. That gives me 3 carbonates, but I have 3 here already. And that's it. This is the balanced equation, balanced molecular equation. So treat the polyatomic ions as just one thing if you have them on both sides. It makes it a lot easier to balance. Next, we write the state for each substance. So if I look at sulfates, sulfates in general, they're soluble. So chromium sulfate, that is going to be a soluble compound. It'll dissolve, split apart into its ions. Ammonium compounds are very soluble. Put a little AQ. Ammonium sulfate, that'll be soluble. But in general, carbonates, except for elements with group 1 like sodium or potassium, those are insoluble. So we'll put an S for solid. Because it's insoluble, it doesn't dissolve, it's a solid. And in fact, these will react here. This falls to the bottom of the test tube in a precipitation reaction because it's a solid. Once we have the states, we can split the strong electrolytes into their ions for the complete ionic equation. So chromium, we can't tell the charge just looking at it. It's a transition metal. Sulfate ion, the whole thing is 2 minus. Good one to remember. So 3 times 2 minus, that's 6 minus. We have to have the 3 plus for the chromium. So this is all a neutral compound. So chromium 3. So we have 2 chromium 3 ions. I'll write aqueous at the end. Plus 3 sulfate ions. Plus the ammonium ion, good one to remember, always has a 1 plus. And the carbonate, that's always 2 minus. So we have 3 times 2, 6 ammonium ions. Then we have 3 of these carbonate ions. So these are the reactants in the net ionic equation. For the products, we have 3 times 2 of these ammonium ions. So again, 6 ammonium ions and 3 sulfate ions. With net ionic equations, we don't split solids apart, so we're just going to write this as is. It'll stay together as this chromium 3 carbonate. And this is the complete ionic equation for chromium 3 sulfate plus ammonium carbonate. Now we can cross out spectator ions. They're on both sides of the complete ionic equation. They haven't changed. We're not interested in them. So I'm looking for things here, and I can see that I made an error here right now. I just put 1 sulfate ion, but if you look at that, there's a 3 as our subscript. So this needs to be 3 sulfate ions. So I have sulfate, 3 sulfate ions here in the reactants and in the products. So because of that, I can cross those out. They're the same. 6 ammonium ions in the reactants and 6 in the products. I can cross those out. What's left is the net ionic equation for this chromium 3 sulfate plus ammonium carbonate. I'll clean it up. We'll have our net ionic equation. And this is the balanced net ionic equation for chromium 3 sulfate plus ammonium carbonate. You'll note that charge is conserved. We have 2 times 3 plus, that's 6 plus. 3 times 2 minus is 6 minus. So that's 6 plus and 6 minus. They give us a net charge of 0. We have a net charge of 0 over here. This is a neutral compound. If you count the atoms up, they'll be the same on both sides as well. This is Dr. B with the balanced net ionic equation for Cr2 SO4 3 plus NH4 2 CO3, chromium 3 sulfate plus ammonium carbonate. This is Dr. B, and thanks for watching.